We are going to start our new lesson. Heat. Right. Heat is the form of energy. Describes the heating as heat. Under that describes heat is a form of energy. Heat is a form of energy. Right? Heat is a form of energy. Full stop. Heat is the form of energy. And that is right, same point. When heat energy is provided, to a substance, heading is heat, and that we have written heat is the form of energy. Same point and continue. When heat energy is provided to a substance, its temperature is increased. Its temperature is increased. Right? So, what are the other forms of energy here? What are the other forms of energy that you know? Kinetic energy, potential energy, now sound energy. Any other forms? Light energy. So there are many other forms of energy. Right? So like that, heat is also a form of energy. Heat is also a form of energy. Therefore, amount of heat energy is measured by unit of all these energy measured in joule. Therefore, amount of heat energy is also measured in joule. Right? Star point and right. The SI unit of star point and right. The SI unit of the amount of energy is joule. Is joule. The SI unit of the amount of energy is joule. Next star point. Next star point. The SI unit of temperature is Kelvin, capital K. Kelvin. The SI unit of temperature is Kelvin. First of all, Celsius is also widely used. But Celsius is also widely used to measure the temperature. But Celsius is also widely used to measure the temperature. Next point. The following equation can be used. The following equation can be used to measure. The following equation can be used to measure. Used to convert. The following equation can be used to convert Celsius into Kelvin. The following equation can be used to convert Celsius into Kelvin. Right? You know it even from O levels, therefore I will give it. What's in here? T equals theta plus 270. Unit is Kelvin. So theta is the temperature in Celsius. Theta is the temperature in Celsius. What is T here? T is is the temperature in Kelvin. Just write this here. Temperature in Kelvin. You have learned this equation in O-level, but in advanced level, we'll explain this equation further. We teach a lot of things about Celsius and Kelvin. We teach a lot of things about Celsius and Kelvin, but not now. I just want to give this equation at the beginning. The only thing that I want to tell you here, heat is a form of energy. When we provide heat, energy, temperature is increased. The temperature is measured, the SI unit of temperature is Kelvin, but widely, in many of the places, at many of the times, we use Celsius. So we want to know how to convert a Celsius temperature into a Kelvin temperature. That's it. But we will learn a lot of things about Celsius and Kelvin later on. Put number 1 and write your first subheading. Heat capacity of an object. Heat capacity of an object. Within brackets S. Heat capacity of an object. Within brackets S. Right. Listen to me carefully. Listen very, very carefully. I have said that when heat energy is given, temperature is increased. That's the first concept. So let's say there is an object. An object. We don't know the mass of the object. What's the special thing here? There's an object. We don't know what the mass is. We don't know what the mass is. We provide some heat energy. We provide some heat energy. We provide capital Q joules of heat energy. Then what should happen here? Then the temperature of this object should be increased. Let me take initial temperature of this object to be theta degree Celsius. And let me take temperature of this object is now theta plus 1 degree Celsius. So therefore, what should be the increase in temperature? What should be the increase in temperature? The initial temperature is theta, final temperature is theta 2. Therefore, the increase in temperature. Increase in temperature is theta 2 minus theta 1. How much? Initial temperature theta, final temperature theta plus 1. Therefore, increase in temperature is 1 degree Celsius. The amount of heat energy needed for any object to increase the temperature by 1 degree Celsius is said to be its heat capacity. So you should write the heading as heat capacity of an object S. You should draw the figure and write down everything. Listen here. Let's say the temperature of this object, initial temperature, for example, let's say 30 degrees Celsius. So what is the initial temperature here? 30 degrees Celsius. final temperature, let's say 31 degrees Celsius. So what is the increase in temperature? 1 degree Celsius. Let's say to do it, we have given 200 joules of energy. So what has happened? When we give 200 joules of heat energy, temperature of the object is increased from 30 degrees Celsius to 31 degrees Celsius. 30 plus 1, 31. Then it is said that heat capacity of this object is 200 joules. Got it here? Then how much heat energy is needed to increase the temperature of the object from 31 degrees Celsius to 32 degrees Celsius? That is also 200 joules. Clear? Then how much heat energy needed to increase the temperature from 32 degrees Celsius to 33 degrees Celsius? That is also 200 joules. Clear? So how much heat energy will be needed to increase the temperature from 2000 degrees Celsius to 2000 degrees Celsius to 2001 degrees Celsius? That is also 200 joules. Clear? So whenever we increase the temperature by 1 degree Celsius, we have to give an amount of energy of 200 joules. Clear? So 200 is the special property of this object, which is said to be the heat capacity of the object. Correct? Right. Below this figure, write the definition. The amount of heat energy, the amount of heat energy needed, the amount of heat energy needed to increase the temperature, the amount of heat energy needed to increase the temperature, of an object, to increase the temperature of an object by a unit, the amount of heat to increase the temperature of an object by a unit, the amount of heat needed for an object to increase the temperature by a unit, is defined as its heat capacity. Is defined as its heat capacity. Extra point. The SI unit of the SI unit of heat capacity. The SI unit of heat capacity. The SI unit of heat capacity is, look at what, joules per Kelvin. Joules per Kelvin. Look at what I write. Joules per Kelvin. The SI unit of heat capacity is joules per Kelvin. Within brackets, but joules per degree Celsius. But joules per degree Celsius is also used. But joules per degree Celsius is also used as a unit. Joules per degree Celsius is also used as a unit of heat capacity. Clear? So what is the SI unit of heat capacity? Joules per Kelvin. But in most of the books you will find the units joules per degree Celsius. And the relationship is 1 joule per Kelvin. 1 joule per Kelvin is equal to 1 joules per degree Celsius. Let's write this relationship also. Joules per Kelvin and joules per degree Celsius are equal. Right. After everything, I'm going to obtain an equation. So I'm going to obtain 5 such equations. If you know these 5 equations, more than 80% of heat essay questions can be answered. If you know all the 5 definitions, if you know all the 5 equations, more than 80% of heat essay questions can be completed. But the problem, not the essay questions, the structured essay paper. Why? Second structured essay question is given from heat essay. To answer that structured essay question, these 5 equations cannot help you. To answer the second structured essay question, you should know all the 10 practicals. How many practicals are there? There are about 10 practicals. One of the practicals asked in each and every year. So you should know all the heat practicals. Do you want to do the practicals? If you have more free time, you can try it. But the important thing is not doing the practicals, but writing the practicals in passive voice, including all the details. Practical එක කරනකොට වඩා මොකද වෙන්න ඕන? කෙරුවා වගේ ලියන්න පුළුවන්. කෙරුවා කරලා ලියන්න වෙන fail වෙනවා. Right. So please write example. Example. Is right. The heat capacity of a certain metal ball. The heat capacity of a certain metal ball is the heat capacity of a certain metal ball is 200 joules per degree Celsius. Joules per degree Celsius. Heat capacity of a certain metal ball is 200 joules per degree Celsius. Full stop. How much heat energy is needed? How much heat energy is needed to increase its temperature from? How much heat energy is needed to increase its temperature from 30 degrees Celsius to 34 degrees Celsius? How much heat energy is needed to increase its temperature from 30 degrees Celsius to 34 degrees Celsius? Look at both. I know that you can get the answer at once, but I want to teach you something. Even from your O-level knowledge, I know that you can get the answer, but that is something else. Initial temperature of the metal ball 30 degrees Celsius. Final temperature of the metal ball should be 34 degrees Celsius. So what should be the increase in temperature? Temperature should be increased from 30 to 34. So what is the increase in temperature? You must answer me. 34. 4 degrees Celsius. So increase in temperature is 4 degrees Celsius. Right. First of all, please draw this figure here. We are going to obtain 5 important equations. Please follow all the guidelines. Please follow all the advices. Draw the figure, write down everything, and please wait until I explain the things. So here I am going to prove our first equation. But to prove it, I am going to write some statements. By writing several statements, I am going to prove the first equation. Which write the heat capacity of the object. Here is a metal ball. Heat capacity of the object equals S. So not S, 200. Sorry. Heat capacity of the object 200 joules per degree Celsius. Joules per degree Celsius. Heat capacity of the object equals 200 joules per degree Celsius. Next statement. Therefore, the amount of heat energy. Therefore, the amount of heat energy needed to increase. Therefore, the amount of heat energy needed to increase the temperature of the object by 1 degree Celsius. Therefore, the amount of heat energy needed to increase the temperature of the object by 1 degree Celsius. By 1 degree Celsius. That is 200 joules. That is the definition of heat capacity. That is the definition of heat capacity. So what are the two statements? Let me repeat them. What's the first statement? The heat capacity of the object equals 200 joules per degree Celsius. Second statement. Therefore, the amount of heat energy needed to increase the temperature of the object by 1 degree Celsius. 200 joules. I think now you can guess the fifth one. So please write therefore the amount of heat energy needed to increase the temperature of the object by 4 degrees Celsius. Therefore, the amount of heat energy needed to increase the temperature of the object by 4 degrees Celsius. By 4 degrees Celsius. Put the equation mark and wait. Do not write anything. Wait until I give you this calculations. Do not multiply. Therefore, the amount of heat energy needed to increase the temperature of the object by 4 degrees Celsius. How do you find it? To increase the temperature by 1 degree, you have to give 200 joules. Therefore, to increase the temperature by 4 degree, 200 should be multiplied by 4. Do not multiply. Keep the answer like this. I know that you are able to multiply by 200 by 4, but do not multiply. Keep them as they are. Right. Put another equation mark and write. Without writing 200 into 4, I can write this as 4 into 200. Any difference here? Any difference? 200 into 4 is 800. 4 times 200 is also 800. And finally, we are going to write this relationship. Look at what. If we want Q joules of heat energy, look at what. If we want Q joules of heat energy to increase the temperature by 4 degrees Celsius, right? If we want Q joules of heat energy to increase the temperature by 4 degrees Celsius, Q is given by the product 4 into 200. Am I right here? So here 4 is the heat capacity. 4 is the heat capacity within brackets S. That's a letter E. And 200, sorry, what's it here? Sorry, 200 is the heat capacity. 200 is the heat capacity. What is 4 here? 4 is the change in temperature. The change in temperature. Let's write this equation. 200 is the heat capacity. 4 is the change in temperature. It is said to be theta. Change in temperature is normally indicated by theta. Right now, read everything. Check whether you can understand the concept. The example. Check whether you can understand them all. So if you are okay with this example, let's try for another example. Is right. The heat capacity of a piece of wood. The heat capacity of a piece of wood. The heat capacity of a piece of wood is look at what? 40 joules per degree Celsius. The heat capacity of a piece of wood is 40 joules per degree Celsius. How much heat energy is needed? How much heat energy is needed to increase its temperature from 30 degrees Celsius to 30 degrees Celsius to 50 degrees Celsius. How much heat energy is needed to increase its temperature from 30 degrees Celsius to 50 degrees Celsius? You should draw this figure way and should write all the statements as they are in the previous example. Like in the previous example, write all the statements and get the final answer. The final answer should be kept as a product. You should not multiply. The final temperature 50 degrees Celsius, initial temperature 30 degrees Celsius. Now the increase in temperature is 20 degrees Celsius. So draw the figure, write the statements as we have written in the previous example, and try to obtain the answer. Do it. So what are the statements here? The heat capacity of the object 40 joules per degree Celsius. This is the first statement. Who has written the first statement correctly? The heat capacity of the object equals 40 joules per degree Celsius. So what should be the next statement? Therefore, the amount of heat energy needed to increase the temperature by 1 degree Celsius. Therefore, the amount of heat energy needed to increase the temperature by 1 degree Celsius is 40 joules. Who has written the second statement correctly? Therefore, the amount of heat energy needed to increase the temperature by 1 degree Celsius, 40 joules. Final statement, therefore, the amount of heat energy needed to increase the temperature by 20 degrees Celsius. What's the next statement? Therefore, the amount of heat energy needed to increase the temperature by 20 degrees Celsius, that is 40 joules needed for 1 degree Celsius to increase the temperature by 20 degrees Celsius, 40 times 20. Question that statement also. So finally, we can write that. Therefore, the amount of heat energy needed for this process is Q. Q is equal to the product 40 into 20. 40 into 20. 40 is the heat capacity. 20 is the temperature change. Please write this equation also exactly like this and identify the terms like this. Start. If you want, you can write 20 into 40 or 40 into 20. It's not a problem. So this is one of the equations that we want to obtain. I did not ask such a big thing. You just want to obey the statements that you have written in the example number 1, in the example number 2. Only the numerical values are different. So the statements are same. Okay? Example number 3. Example number 3. Is right. The heat capacity of a certain object. The heat capacity of a certain object is, look at the board. The heat capacity of a certain object is S joules per degree Celsius. Per degree Celsius or per Kelvin, no problem. The heat capacity of a certain object is S joules per degree Celsius. Let's stop. How much heat energy is needed? How much heat energy is needed to increase the temperature? How much heat energy is needed to increase the temperature of the object by theta degree Celsius? How much heat energy is needed to increase the temperature of the object by theta degree Celsius? By theta degree Celsius. Look at board here. There's a certain object. I don't care about the size and shape. There is an object. We want to increase the temperature of this object by theta degree Celsius. The meaning is this here. The meaning is this. Look at both. Initial temperature theta 1 degree Celsius. Final temperature theta 2 degree Celsius. The final temperature is equal to theta 1 plus theta. Can you understand this simple math? Initial temperature theta 1. Final temperature theta 1 plus theta. So what is the increase in temperature? Theta degree Celsius. Okay? So this way. For this process, we need some heat energy. The amount of heat energy needed for this process is capital Q joules. So here, the increase in temperature. Increase in temperature in this process is theta degree Celsius. Please draw the figure and wait. Draw the figure and wait. Right, who wants more time to do the figure? Right, now let's write statements together. Abhi ikut wela lihat statements, yeah? The heat capacity of the object is S within brackets joules per degree Celsius. Heat capacity of the object equals S within brackets joules per degree Celsius. Even it is joules per Kelvin, no problem. Next statement. Next statement. Therefore, the amount of heat energy needed. Therefore, the amount of heat energy needed to increase the temperature of the object. Therefore, the amount of heat energy needed to increase the temperature of the object by 1 degree Celsius. Therefore, the amount of heat energy needed to increase the temperature by 1 degree Celsius. That is S joules. S joules. Okay. Therefore, the amount of heat energy needed to increase the temperature of the object by 1 degree Celsius is S joules. Next statement. Therefore, the amount of heat energy needed to increase the temperature of the object by theta degree Celsius. Therefore, the amount of heat energy needed to increase the temperature of the object by theta degree Celsius. Therefore, the amount of heat energy needed for the object to increase the temperature by theta degree Celsius. How do we find it? To increase the temperature by 1 degree Celsius, we need S joules of heat energy. Therefore, to increase the temperature by theta degree Celsius, we want S times theta joules. So this is the amount of heat energy needed for this process. Clear? Any doubt? So if the heat energy needed for this process is Q, now Q is given by the product S into theta. So this is the first equation that I wanted to prove. We are going to prove how many such equations here? 5 such equations. If you know those 5 equations, you can answer almost 80% of these equations. Right? But the problem, not these equations, the problem is the structured essay. For the structured essay, you have to learn at least 10 practicals. One of the practical is asked every year. But let's try to complete the easier thing. The easier thing is the 5 equations at this area. Let's try to overcome that problem first. So S is heat capacity. S is heat capacity. So here we did not worry about mass, right? I did not give you mass. No mass is in this equation. Heat capacity. Only heat capacity, and theta means the change in temperature. The change in temperature. Right, so this is the first equation that we want to obtain. So these 5 equations and calculations with the 5 equations somewhat easier when compared to the practicals. Right? But first we'll try to complete the easy things. After that we can try for the practicals and those concepts and the equations given from practicals in structured essay. Right? Fourth and last example. Fourth and last example. Please try. The heat capacity of a certain plastic sphere the heat capacity of a certain plastic sphere is 120 joules per degree Celsius. 120 joules per degree Celsius. Full stop. How much heat energy is needed? How much heat energy is needed to increase its temperature? To increase its temperature from 30 degrees Celsius to 100 degrees Celsius. The heat capacity of a certain plastic sphere is 120 joules per degree Celsius. How much heat energy is needed to increase its temperature from 30 degrees Celsius to 100 degrees Celsius? How much heat energy is needed to increase the temperature from 30 degrees Celsius to look at what 30 degrees Celsius to 100 degrees Celsius. So what is the increase in temperature? Don't try what is the increase in temperature? 100 minus 30 again 70 degrees Celsius. Now look at what if in the exam we draw the figure, but they don't give marks for drawing figure. Then why do we draw it? When we draw a figure, when we mark the given data on the figure, it's very easy for us to understand the question. We draw the figure for us to understand the question well. Once we understood the question well, it's very easy to answer. So drawing figure is essential. After that, we don't write any statements. Do we write statements in the exam? In previous 3 examples, we have written statements for us to understand the concept. We wanted to understand the concept of heat capacity. That's why we have written some statements. In the exam, just draw the figure and write the equation Q equals ST. ST is the heat capacity which is given as 120. The change in temperature is 70. The multiplication is very difficult, so you can do it. Right here. The easiest way to multiply is just write the 2 zeros like this, these 2 zeros, and multiply by 7. 7 times 2, 14, 1 remaining. 7 times 1, 7, with the remaining 1, 8. Very good. 8,400 joules. over this answer. So this is so simple. Just draw the figure, apply the equation at once, and get the answer. Right. The next concept, the next equation that we are going to obtain is this. Look at what it is. Let's say there is a solid object. There is a solid object. What will happen if we provide heat energy to a solid object? There is a solid. If we provide heat energy, what will happen to this solid? Nothing will happen to the solid. The temperature of the solid will be increased. Am I right here? My question is, we provide heat energy, temperature increases. Initial temperature theta 1, after some time theta 2. If you provide heat energy further, temperature is theta 3. If you provide heat energy further, temperature will be theta 4 and so on. My question is, will the temperature be increased forever? Unlimitedly? Or will something happen? Very good. When we provide heat energy, yes, temperature is increased, but at a certain time we see that solid is melting. So it starts to be melted. Got it? And another thing can be observed. When we provide heat energy, temperature continuously increases. At a certain temperature, let's say theta 2 degrees Celsius, under that temperature, when we provide heat energy, the solid started to be converted into its liquid. Got it? But there's a magical thing happens here. The magic, the most wonderful thing. When I was a student, when my teacher told me for the first time, it was like a magic for me. What is the magical thing here? Even we provide heat energy, when a solid is being converted into its liquid, the temperature remains unchanged. That is the magic. I was not even able to believe it at that time, the time when I hear it. What's it here? When we provide heat energy to a solid, the temperature continuously increases. But once it reaches to a certain temperature, even we provide heat energy further, temperature not increased. Temperature remains unchanged, but the solid is being converted into its liquid. This special constant temperature has a name. What is it here? The temperature is constant, but it has a special name for this temperature. What is it here? No. Let's write not and draw this figure. Not and draw this figure, including all the details. Below this figure, please write. Below the figure, please write. When heat energy is given to a solid, when heat energy is given to a solid, its temperature is increased. When heat energy is given to a solid, its temperature is increased. Its temperature is increased. Its temperature is increased. When heat energy is given to a solid, its temperature is increased. But when the temperature of the object, reaches to a certain value, the temperature remains unchanged. The temperature remains unchanged. The temperature remains unchanged, even the heat energy is continuously provided. The temperature remains unchanged, even the heat energy is continuously provided. Even the heat energy is continuously provided. Full stop. At that same point, or you can use a different star point. At that temperature, it can be observed that the solid is being converted. Into its liquid. At that temperature, it can be observed that the solid is being converted into its liquid. Full stop. Final stop point. That special constant temperature. Final stop point. That special constant temperature is known as it's a different color pen and write. Now you will know. It's known as the melting point of the solid. It's known as the melting point of the solid. It's known as the melting point of the solid. Okay, yeah? So if you do not have another color pen, highlight the term melting point or at least underline the words melting point. Right? So here we provide heat energy, the temperature remains unchanged, but the solid is being converted into its liquid. This constant temperature is said to be the melting point. The melting point of the solid. Now we come to the next case. So at the very beginning of this observation, scientists knew that when we give heat energy, temperature is increased. But at the melting point, we give heat energy, nothing will happen to the temperature. We give heat energy, but temperature is not increased. Therefore, at the very beginning, those days, this heat energy was a mysterious concept, mysterious thing for the scientists. Therefore, they didn't say mysterious. They used the word latent. What's the word that they used here? latent heat. This is one kind of latent heat. You will learn another kind of latent heat today. Yeah. Just write your next subheading, latent heat. Latent heat. Okay? Latent heat. And that is why normally when heat energy is given to a solid, its temperature is increased. Normally when heat energy is given to a solid, temperature is increased. But when heat energy is given to a solid, at its melting point, the temperature is not increased. But when heat energy is given to a solid at its melting point, the temperature is not increased. Therefore, that heat energy was named. I don't know the person who gave this name. Therefore, that heat energy was named as, it's a different color we can write. That heat energy was named as latent heat. What heat there? Latent heat. Okay? Look at what we in physics, especially in heat lesson, to save 1 kilogram, use a special word. What's it? Wherever you see that word, you must understand that is 1 kilogram. To save 1 kilogram, use the word specific. So wherever you see this word in heat lesson, the meaning is 1 kilogram. Okay? So scientists have defined another term, specific latent heat of a solid. What does it mean? Specific latent heat of a solid means you take how many kilogram here? You take a solid but 1 kilo. The amount of heat energy needed for 1 kilogram of a solid to be completely converted into its liquid. Therefore, you get 1 kilogram of liquid. The amount of heat energy needed for 1 kilogram of a solid to be completely converted into its liquid at its melting point is defined as the specific latent heat. Okay, dear? Right. So please write your next subheading, specific latent heat of converting a solid into liquid is said to be fusion. What's the word that we use here? Fusion. Specific latent heat of fusion of a solid. Specific latent heat of fusion of a solid. Specific latent heat of fusion of a solid. Draw this figure and wait. Draw the figure and all the given data. What's the heading there? Specific latent heat of fusion of a solid. Fusion means converting a solid into liquid. Converting a solid into a liquid. Here, the meaning at this point is converting a solid into liquid. Who wants more time to draw the figure? Lamont? Who wants more time to draw this figure? Nobody wants. Wow. Liam. The amount of below the figure. The amount of heat energy needed. The amount of heat energy needed for a unit mass of a solid. The amount of heat energy needed for a unit mass of a solid. For a unit mass of a solid to be completely converted. The amount of heat energy needed for a unit mass of a solid to be completely converted into its liquid, at its melting point. To be completely converted into its liquid at its melting point, is defined as the specific latent heat of fusion of the solid. Specific latent heat of fusion of the solid. the amount of heat energy needed for a unit mass of a solid to be completely converted into its liquid at its melting point, comma, is defined as the specific latent heat of fusion of the solid. Okay, yeah? You should remember this definition. When it is asked in the examination, you must be able to write the definition. So you have to remember it. Okay. Let's try for example number 1. Example number 1. Let's write the specific latent heat of fusion of a certain plastic. The specific latent heat of a certain plastic. Specific latent heat of fusion. Specific latent heat of fusion of a certain plastic is 400 joules. Check the unit, joules per kilogram. 400 joules per kilogram. Its melting point is 70 degrees Celsius. Its melting point is 70 degrees Celsius. 70 degrees Celsius. We'll stop. How much heat energy is needed? How much heat energy is needed? How much heat energy is needed to convert 2 kilograms of that plastic material? How much heat energy is needed how much heat energy is needed to convert 2 kilograms of that plastic material to be completely converted into its liquid, to be completely converted into its liquid at its melting point, to be completely converted into its liquid, comma, at its melting point, at its melting point. Look at what here. Look at what. So how many kilograms have they given us here? 2 kilograms. This is a plastic. The melting point is given as 70 degrees Celsius. At the 70 degrees Celsius, it means at the melting point, how much heat then should be given for this solid plastic to be converted into liquid of the plastic. Liquid of the plastic, or plastic liquid. The temperature remains unchanged as 70 degrees Celsius. That's no change in temperature. Got it? Draw the figure and please wait until I give you the statements. Don't write anything, just draw the figure and mark the data only and wait until I give you the statements. Start here. Right, please write the first statement. First statement. Specific latent heat of fusion of the plastic. Specific latent heat of fusion of the plastic, that is given as 400 joules per kilogram. Kilo eකට joule 400 තුනම දිය වෙලා යනවා. That's the meaning. Right? First statement, specific latent heat of fusion of the plastic 400. What's the meaning of unit mass? Unit mass means 1 kilogram. I forgot to tell you. Unit mass means 1 kilogram. Next statement. To write this, after that please write, therefore the amount of heat energy needed, to convert 1 kilogram of the plastic, therefore the amount of heat energy needed to convert 1 kilogram of the plastic completely into its liquid. Therefore the amount of heat energy needed for 1 kilogram of the plastic to be completely converted into its liquid equals 400 joules. 400 joules. If you give 400 joules to the plastic, when the plastic is at its melting point, 1 kilogram of solid plastic will be converted into 1 kilogram of plastic liquid. That's the meaning, right? The final statement. Therefore, the amount of heat energy needed, to convert, 2 kilogram of the plastic, completely into its liquid. How do we find it? Do not multiply. Therefore, the amount of heat energy needed for 2 kilogram of the plastic to be completely converted into its liquid. How much? For 1 kilogram, 400. For 2 kilogram, 800. I know that, but please write it as 2 into 400. For 400 into 2 joules. Do not multiply. Leave the answer as it is, like this, as a product. Do not multiply. I know that you have to multiply. Right. Read the 3 statements, check whether you can understand. Read them all and check whether you can understand. Right. Now look at what here. To convert 2 kilogram of solid plastic completely into the liquid, let's say we want Q joules of heat energy. How much will be Q joules of heat energy? That Q joules of heat energy is given by the product 2 into 400. What is 2 here? 2 is mass, 400 is the specific latent heat of fusion. Right, so let me write it separately. The amount of heat energy needed for this process is Q. Q is given by the product 2 into 400. Let's write this equation, go box around it, and this clearly indicates that this 2 is the mass of the solid. 400 is the specific latent heat of fusion. specific latent heat of fusion. So this is the second equation that I wanted to do. Okay, I think it's much clearer, right? Difficult. Right, now let's try for the second example. For the previous case, I have given 4 examples. Here, I will give only 3 examples because now you have understood the concept. Second example, please try. The specific latent heat. Example number 2. I will not erase anything on the board. Number 2 and write. Specific latent heat of fusion. Specific latent heat of fusion of a certain solid material. Specific latent heat of fusion. Specific latent heat of fusion of a certain solid material is look at what simple L within brackets joules per kilogram. L joules per kilogram. Simple L joules per kilogram. Okay, dear? How much heat energy is needed? How much heat energy is needed? How much heat energy is needed for? How much heat energy is needed for? Look at board. Simple m kilogram of that solid. Look at board and write simple m kilogram of that solid. How much heat energy is needed for simple m kilogram of that solid to be completely converted into its liquid at its melting point. How much heat energy is needed for simple m kilogram of that solid to be completely converted into its liquid at its melting point. Look at board here. So how many kilogram of solid is given here? Simple m kilogram of the solid is given. This is a solid. We want to convert the total, all the m kilogram of solid into its liquid at its melting point. Please draw this figure. It's important to draw the figure. Draw the figure, please. Draw the figure and wait. Do not write anything. Just draw the figure and mark the data only. Don't do anything else. So I'll take the melting point as theta. So final temperature will also be theta degree Celsius. So there is no change in temperature. Only the solid is converted into liquid. This is said to be a phase change. PHASE. Phase change. It means solid phase to liquid phase. Right? I'll give note for all these words, but just draw the figure. Right. I think you have drawn the figure. So let's write the statements together. Yeah. Specific latent heat of fusion of the solid, not plastic. Specific latent heat of fusion of the solid equals, earlier it was 400, now it is simple L within brackets joules per kilogram. Specific latent heat of fusion of the solid equals simple L within brackets joules per kilogram. Joules per kilogram. Right? Next statement. Next statement. Therefore, the amount of heat energy needed. Therefore, the amount of heat energy needed to convert 1 kilogram of the solid. Therefore, the amount of heat energy needed to convert 1 kilogram of the solid completely into its liquid. Therefore, the amount of heat energy needed to convert 1 kilogram of the solid completely into its liquid equals, for 1 kilogram we need L joules of heat energy. That is the definition of fusion. That's the definition of simple energy. What it is? Now the amount of heat energy needed to convert 1 kilogram of that solid completely into its liquid is L joules. How many kilograms given here? How many kilograms are given here? M kilograms. Okay. So please write your next statement. Therefore, the amount of heat energy needed. Therefore, the amount of heat energy needed to convert simple M kilogram of the solid. Therefore, the amount of heat energy needed to convert simple M kilogram of the solid. To convert simple M kilogram of the solid completely into its liquid. Therefore, the amount of heat energy needed for simple M kilogram of the liquid, complete simple M kilogram of the solid, completely into its liquid. Here, how do you find it? Amount of heat energy needed for M kilogram of the solid to be completely converted into its liquid. To be completely converted into its liquid is 1 kilogram we need L, for M kilograms we want M into L. Unit is joule. Am I right? Did I make any mistakes while I was reading the statements? No, right? Read the three statements, see if you can understand. Read them all. So finally, if the amount of heat energy needed for this process is Q, Q is given by the equation M into L. The heat energy needed for M kilogram of the solid to be completely converted into its liquid at the melting point is M into L. And Q equals Q equals ML. M into L. So this is the second equation out of those 5 that I wanted to do. Just write the equation like this and identify terms in it. So in the exam, no need to prove the equation, you can directly use. But today I proved it, otherwise normally science students, they don't believe the things if we do not prove them. But the things are not proved, they don't believe. That's how their brains work. Okay. Any doubt? If you have doubt, please ask. Let's try for one more example. Example number 3. Example number 3. Specific latent heat of fusion of ice. Specific latent heat of fusion of ice. Specific latent heat of fusion of ice is approximately 3.2 into 10 to the power 5 joules per kilogram. Specific latent heat of fusion of ice is approximately 3.2 into 10 to the power 5 joules per kilogram. Full stop. How much heat energy is needed? How much heat energy is needed for 200 grams of ice? 200 grams of ice to be completely converted into its liquid at its melting point. How much heat energy is needed for 200 grams of ice to be completely converted into its liquid at its melting point? At its melting point. Okay. No need to draw figure because we are tired of drawing so many figures. At once apply the equation Q equals simple L into simple L and try to obtain this answer. This is approximately correct, right? Try to find the answer here. Huh? Yes. MB is 200 gram. You cannot work with grams. Grams must be converted into kilograms. Therefore, this should be divided by 1000. L is the amount of heat and needed to convert 1 kilogram of ice into liquid. Liquid means water. To convert 1 kilogram of ice into liquid water, it needs 3.2 into 10 to the power 5. Then to convert this much of kilogram, multiply. So that is 3.2 into 10 to the power 5. Look at board here. 2 of the zeros can be cancelled out like this. 10 to the power 5 divided by 10 here. 10 to the power 5 divided by 10 here. You have 2 into 3.2. 10 to the power 5 divided by 10 means 10 to the power 4. I will simplify this further. 2 into 10, 3.2 can be written as 32 over 10. If you divide 32 by 10, that will be 10 to the power 2. 10 to the power 4 means 1, 2, 3, 4 zeros. 10 to the power 4 means 4 zeros. So this 0 and this 0 can be cancelled out. So what are the remaining numbers then? 2, 32 and 1000. In order, 64,000 joules. What is that? 64,000 joules. Not easy, right? 64,000 joules. Who got this answer? Lamai? Right, now we are going to go to the third concept. The third concept is, look at board here. Now we have a liquid, right? Let's say there is a liquid. Look at board here. Now we don't have a solid, there is a liquid. A question is, when there is a liquid, if you provide heat energy to a liquid, what will happen? If you provide heat energy to a liquid, what will happen? The temperature of the liquid is increased. If the initial temperature is 1 degree Celsius, the final temperature will be 2 degree Celsius. So what will happen here? When heat is provided to a liquid, its temperature increases. My question is, will the temperature be increased forever, continuously, without ending? No. When you provide heat into a liquid, when the liquid reaches to a certain temperature, then that temperature becomes constant. Even you provide heat in it continuously, the temperature will not be increased. That special temperature is known as Lamai. That special temperature is known as. So you remember everything. I'm so happy. All other science, boiling point. Boiling point. So please write your next heading. Boiling point of a liquid. Boiling point of a liquid. Right. And that is right when heat energy is provided to a liquid. When heat energy is provided to a liquid, its temperature is increased. When heat energy is provided to a liquid, its temperature is increased. Its temperature is increased. First of all, but when the temperature of the liquid reaches to a certain value, but when the temperature of the liquid reaches to a certain value, but the temperature of the liquid reaches to a certain value, comma, the temperature is not further increased. The temperature is not further increased. The temperature is not further increased. Even the heat energy is continuously provided. Even the heat energy is continuously provided. Even the heat energy is continuously provided. Full stop. That special constant temperature, that special constant temperature, that special constant temperature is known as the boiling point of the liquid. That special temperature is known as the boiling point of the liquid. That special temperature is known as the boiling point of the liquid. Right. Look at the word here. So now they say theta 2 is the boiling point. Now we provide further heat energy. Then what will happen? At the boiling point, we provide further heat energy. But temperature will not be any further increased. Then what will happen to that heat energy? That heat energy is used to convert the liquid into its the liquid into its vapor. That heat energy is used to convert the liquid into vapor. The temperature remains unchanged as theta 2 degrees Celsius. The special temperature, this special constant temperature is known as the boiling point. The boiling point. Okay, dear? Draw the figure. Very important of drawing diagrams. When you draw diagrams, I will remember what. Right. So wait. Start going. I think you have got the figure. I have given more than enough time. So I think you have got the figure. So please write start going. The heat energy, the heat energy provided to a liquid, the heat energy provided to a liquid, the heat energy provided to a liquid at its boiling point, the heat energy provided to a liquid at its boiling point, at its boiling point, at its boiling point, comma, is not used to increase the temperature. Is not used to increase the temperature. The heat energy provided to a liquid at its boiling point is not used to increase the temperature. Full stop. That temperature, therefore, that heat energy was named as, I don't know the person who gave that name. Therefore, that heat energy was named as, look at board, use a different color pen and write latent heat of vaporization. Latent heat of vaporization. I don't know the person who gave his name, maybe a scientist, most probably should be a scientist. Therefore, that heat energy was named as latent heat of vaporization. Clear? Right. If you put the word specific, what does it mean? Latent heat of vaporization means any kilogram of the liquid. Specific latent heat of vaporization, 1 kilogram of the liquid. Specific means always 1 kilogram. Right? You should have one specific person in your life, right? So latent heat of vaporization. Next point. The heat energy provided to a liquid at its boiling point. Heat energy provided to a liquid at its boiling point. Heat energy provided to a liquid at its boiling point, comma, is used to convert the liquid into its vapor. The heat energy provided to a liquid at its boiling point, comma, is used to convert the liquid into its vapor. Okay, yeah? Right. Now I'm going to use this word with this. What's the word I'm going to use? Specific. Specific latent heat of vaporization. Please write your next subheading. Specific latent heat of vaporization within brackets, capital L, not simple L. Specific latent heat of vaporization. Is it vaporization? Right, look at board here. Now I will take, look at the board. Heading is specific latent heat of vaporization. Now I'll take specific mean 1 kilogram. In physics, 1 kilogram is normally said to be a unit mass. What mass here? Unit mass. So I take a unit mass of a liquid. It means 1 kilogram of liquid. It's kept at boiling point. Let me take boiling point to be 800 degrees Celsius. 800 degrees Celsius. Right? Then I provide some heat energy. I provide Q joules of heat energy. And then I convert the liquid into its vapor. Liquid into its vapor. I get exactly 1 kilogram of liquid weight at the end. The amount of heat energy needed for this process is said to be the specific latent heat of vaporization of this liquid. Okay? It's simple. How much energy is needed for 1 kilogram of a liquid to be completely converted into its vapor at its boiling point? I'll give you the definition, don't worry. I'll draw the figure. Draw the figure. Below the figure, please write. Below the figure, please write the amount of heat energy needed. Below this figure, please write the amount of heat energy needed to convert. The amount of heat energy needed to convert. The amount of heat energy needed to convert a unit mass of a liquid. The amount of heat energy needed to convert a unit mass of a liquid. A unit mass of a liquid completely into its vapor. Completely into its vapor. Completely into its vapor. At its boiling point, the amount of heat energy needed to convert a unit mass of a liquid completely into its vapor at its boiling point, comma, is defined as the specific latent heat of vaporization of the liquid. Specific latent heat of vaporization of the liquid. Okay, dear? Specific latent heat of vaporization of the liquid. Right. Now let's try for an example. So it means I'm trying to obtain the third equation. Right? So please write example. The specific latent heat of vaporization of a certain liquid. The specific latent heat of vaporization of a certain liquid is 700 joules per kilogram. Specific latent heat of vaporization of a certain liquid is 700 joules per kilogram. Full stop. How much energy is needed? How much energy is needed? How much energy is needed for 3 kilogram of that liquid? How much energy is needed for 3 kilogram of that liquid to be completely converted? Into its vapor, to be completely converted into its vapor at its boiling point. How much heat energy is needed for 3 kilogram of that liquid to be completely converted into its vapor at its boiling point? Right, please quickly draw this figure. This is the last time that we draw this figure. The 3 kilogram is the mass. The liquid is at its boiling point. So we provide some heat energy and we get 3 kilogram of the vapor. 3 kilogram of the vapor. That's it. Drawing please. Right. Please write who wants more time for the figure? Right. Below the figure, let's write the statements. Yeah. Specific latent heat of vaporization of the liquid. Specific latent heat of vaporization of the liquid. 700. That would mean 700 joules per kilogram. Specific latent heat of vaporization of the liquid equals 700 joules per kilogram. Okay, next statement. Therefore, the amount of heat energy needed for 1 kilogram of the liquid. Therefore, the amount of heat energy needed for 1 kilogram of the liquid to be completely converted into its vapor. Therefore, the amount of heat energy needed for 1 kilogram of the liquid to be completely converted into its vapor, equals 700 joules. 700 joules. Okay, dear? 700 joules. Next statement. Therefore, final statement. Therefore, the amount of heat energy needed. Therefore, the amount of heat energy needed for 3 kilogram. For 3 kilogram of the liquid. Therefore, the amount of heat energy needed for 3 kilogram of the liquid. 3 kilogram of the liquid to be completely converted into its vapor, right? Therefore, the amount of heat energy needed for 3 kilogram of the liquid to be completely converted into its vapor. For 1 kilogram, it needs 700 joules. For 3 kilograms, it needs 700 times 3. This much of energy is needed. So please write E equals 700 into 3. 700 into 3. Okay, dear? Is it clear? Read all the 3 statements, check whether you can understand them all. If you have any doubt, please ask, I can help you. Right, so if the amount of heat energy needed for this process is Q, if the amount of heat energy needed for this process is Q, that Q is given by the product 700 into 3. I'll write it as 3 into 700 because both are same thing. 3 into 700 and 703 same. And I'll draw a box around this. This is the next equation that I wanted to obtain. This 3 is the mass of the liquid, and 700 is the what is 700? Just write the equation here. 700 is the specific legal, specific latent heat of vaporization. Specific latent heat of vaporization of the liquid. So this is what I wanted to obtain as our third equation. I think the example is clear. If you have doubts, please ask there. Right? Please don't be silent when you have a doubt. Please do not disturb your friends. You should ask directly from me. Right. Next example. Example number 2. Example number 2 is right. Specific latent heat of vaporization. Specific latent heat of vaporization of a certain liquid. Specific latent heat initial heat of vaporization of a certain liquid is capital L within brackets joules per kilogram. Joules per kilogram. How much energy is needed? How much heat energy is needed? How much heat energy is needed for capital N kilogram? Capital N. How much heat energy is needed for capital N kilogram of that liquid? Capital N kilogram of that liquid to be completely converted. Capital N kilogram of that liquid to be completely converted into its vapor. Into its vapor at its boiling point. Into its vapor at its boiling point. Right. Do not answer the question, read the question. Read it. Okay, is the question clear? Right. So how many kilograms are given? It is given us capital N kilogram of liquid is given. The liquid is at its melting point. We provide some heat energy. The all capital N kilogram of the liquid completely converted into its space. Okay. So please forgive me and draw this figure. The diagrams, the figures are essential to understand the concepts. So please draw. The more you draw, the more you remember. So drawing. Right. So write the first statement. Please write the first statement. Now only you understood, right? Very good. Happy. At least after 5 minutes you have understood. So please write the specific latent heat of vaporization of the liquid. Specific latent heat of vaporization of the liquid. Specific latent heat of vaporization of the liquid equals capital L joules per kilogram. Capital L joules per kilogram. Specific latent heat of vaporization of the liquid equals capital L joules per kilogram. Next statement. Next statement. Therefore, the amount of heat energy needed. Therefore, the amount of heat energy needed. The amount of heat energy needed to convert 1 kilogram of the liquid, 1 kilogram of the liquid completely into its vapor. Therefore, the amount of heat energy needed to convert 1 kilogram of the liquid completely into its vapor, equals capital L within brackets joule. That is the definition. The first two statements explain the definitions. Okay, dear. What's the first statement? Specific latent heat of vaporization of the liquid. Capital L joules per kilogram. Second statement, therefore the amount of heat energy needed to convert 1 kilogram of the liquid completely into its vapor. Capital L joules. Got it here? Right. Final statement. Therefore, the amount of heat energy needed. Therefore, the amount of heat energy needed for capital M kilogram. You can go there, right? For capital M kilogram of the liquid. For capital M kilogram of the liquid to be completely converted into its vapor. To be completely converted into its vapor. Okay, dear. Therefore, the amount of heat energy needed for capital M kilogram of the liquid to be completely converted into its vapor is for 1 kilogram L joules in an M kilograms, M into L. M into L. For 1 kilogram L, for M kilogram, M into L within brackets joule. Clear or not? Is this clear or not clear? Right. So, if the heat energy needed for this process is capital Q, now capital Q is given by the product. If capital Q is the heat energy needed to convert M kilogram of a liquid into M kilogram of a vapor, the amount of heat energy needed for that process is M into L. So please write this equation. Q equals M into L. Both are capital, and name this as the third equation. This is the third thing that I wanted to obtain. M is the mass, L is the specific latent heat of vaporization. Complete here. Write the equation, draw box around it, and identify the terms by using some arrows. Do it. Right, let's try one more example. Let's try one more example for this section. So please write specific latent heat of vaporization of water. Specific latent heat of vaporization of water. Specific latent heat of vaporization of water. Specific latent heat of vaporization of water is approximately 2.25 into 10 to the power 6 joules per kilogram. This is approximately correct, right? Approximately correct. The specific latent heat of vaporization of water is approximately 2.25 into 10 to the power 6 joules per kilogram. 2.25 10 to the power 6 joules per kilogram. How much heat energy is needed? How much heat energy is needed? How much heat energy is needed to convert 2 kilogram of water, 2 kilogram of water completely into its vapor at the boiling point? How much heat energy is needed for 2 kilogram of water to be completely converted into its vapor at its boiling point? At its boiling point. Right. So please directly use the equation Q equals capital ml and do the calculation. Do it here and save your answer to my Zoom chat. Okay, so we use this equation. Look at both. We use this equation. So how much energy is needed for this process? Okay, look at both. M is 2.25 into 10 to the power 6 L is 2 kilograms. Let's multiply. 2 times 5, 10, 1 remaining. 2 times 2, 4 with the remaining 1, 5. Point 2 times 2, 4. 4.5 into 10 to the power 6 joules. This is a huge amount of energy. Next. 4.5, 45, 1 point, and 1, 2, 3, 4, 5, 6. Count 1, 2, 3, 4, 5, 6. Okay. Right. So this much of energy is needed. It's a huge amount of energy. So please remember that to convert water into steam, water into water vapor, huge amount of energy is needed. Got it? Right. Let's go to the next subheading. So it means we are going to obtain the fourth equation. So after we have obtained all the four equations, or the five equations, then we can try for some important questions. Right. Some numerical, some complex questions. So please write the next subheading. Specific heat capacity. Specific heat capacity within brackets C. Specific heat capacity. What's the meaning of the word specific here? 1 kilogram. Earlier we have learned heat capacity. So it means no mass. If you have only heat capacity, means we don't worry about the mass. Specific heat capacity, mass is 1 kilogram. We highly worry about the mass. Okay, dear? So specific heat capacity means, what is heat capacity? Heat capacity is the amount of heat energy needed for an object to increase the temperature by a unit. That's an object. We don't care about its mass. We don't worry about the mass of that object. There is an object, we provide some heat energy, the temperature of the object is increased by a unit, by 1 degree Celsius. Here, there is, I don't care about the object, I care only about the mass. I have an object of mass 1 kilogram. This 1 kilogram is said to be the unit mass. So initial temperature, let me take this as 100 degrees Celsius. We provide some heat energy. Then the temperature is increased from theta degree Celsius to theta plus 1 degree Celsius. Area. So amount of heat energy needed for this process is said to be the specific heat capacity of this material. Material means maybe water, maybe plastic, maybe coconut oil, maybe diesel, maybe petrol, whatever. Or maybe glass, plastic, anything, wood, anything. Clear? So we don't use the term material, only we use the term substance. What is the term that we use here? Substance. Draw the figure. Draw the figure. Clear? So below the figure, please write the definition. Below the figure, please write the definition. The amount of heat energy needed for a unit mass of a substance. The amount of heat energy needed for a unit mass of a substance. The amount of heat energy needed for a unit mass of a substance. For a unit mass of a substance to increase the temperature by a unit. The amount of heat energy needed for a unit mass of a substance to increase the temperature by a unit. To increase the temperature by a unit, comma, is defined as the specific heat capacity of that substance. Is defined as the specific heat capacity of that substance. Let me read it again. The amount of heat energy needed for a unit mass of a substance to increase the temperature by a unit is defined as the specific heat capacity of that substance. Okay, here a substance may be plastic, glass, wood, water, petrol, diesel, anything. But for gases, that's a definition, separate definition. For a gas, you have to consider volume and pressure. So we will learn it later. Right? Let's try for an example. Example number one. Example number one. Yeah. The specific heat capacity of a certain liquid. The specific heat capacity of a certain liquid is, look at board, is 700 joules per kilogram per degree Celsius. You will understand unit later, but you now write it. Sometimes per Kelvin, that is also possible. 700 joules per kilogram per degree Celsius. The specific heat capacity of a certain liquid is 700 joules per kilogram per degree Celsius. How much heat energy is needed? How much heat energy is needed for 3 kilogram? For 3 kilogram of that liquid. For 3 kilogram of that liquid. For 3 kilogram of that liquid. To increase the temperature from 30 degrees Celsius to 40 degrees Celsius. How much heat energy is needed for 3 kilogram of that liquid to increase the temperature from 30 degrees Celsius to 40 degrees Celsius? Okay, dear? Look at board. So what is the initial temperature, Lamai? Initial temperature is 30 degrees Celsius. Final temperature should be 40 degrees Celsius. Here we are considering about 3 kilogram of a liquid. Nothing will happen to the liquid. Liquid will not be converted into vapor. Only the temperature is increased. Got it? Draw this figure. Draw this figure and wait until I give you the statements. Below the figure, let's write the first statement. Yeah. Wait. One more thing. I forgot to tell you. One more thing. What is the increasing temperature? What is the increase in? What is the increase in temperature? Increase in temperature is that is 40 minus 30 and 10 degrees Celsius. Increase in temperature is 30 degrees Celsius. 10 degrees Celsius. Just mark that one also below the figure. Right. Who wants any more time below the figure? No need. Right. Please write the first statement. The specific heat capacity of the liquid. The specific heat capacity of the liquid equals 700 joules per kilogram per degree Celsius. The specific heat capacity of the liquid equals 700 joules per kilogram per degree Celsius. Next statement. Therefore, the amount of heat energy needed. Therefore, the amount of heat energy needed for 1 kilogram of the liquid. For 1 kilogram of the liquid, to increase the temperature by 1 degree Celsius. Therefore, the amount of heat energy needed for 1 kilogram of the liquid to increase the temperature by 1 degree Celsius equals 700 joules. Equals 700 joules. Okay, dear? Right. Next statement. That's the definition of specific heat capacity, right? Next equation, next statement. Therefore, the amount of heat energy needed. Therefore, the amount of heat energy needed for 3 kilogram of the liquid. Therefore, the amount of heat energy needed for 3 kilogram of the object to increase the temperature by 1 degree Celsius. Listen to me carefully and write carefully, otherwise you will write something wrong. Listen to me carefully. Therefore, the amount of heat energy needed for 3 kilogram of the liquid to increase the temperature by 1 degree Celsius. Here, for 1 kilogram, it wants 700 joules. And for 3 kilograms, it wants 700 times 3 joules. 700 times 3 joules. Got it? To increase the temperature of 1 degree Celsius for 1 kilogram, it wants 700. Therefore, to increase the temperature by 1 degree Celsius for 3 kilograms, it wants 700 into 3. 700 into 3. Okay? Final statement. Therefore, the amount of heat energy needed. Therefore, the amount of heat energy needed for. Therefore, the amount of heat energy needed for 3 kilogram of the liquid. 3 kilogram of the liquid to increase the temperature by 3 degrees Celsius. To increase the temperature by 10 degrees Celsius. To increase the temperature by 10 degrees Celsius equals, look at board. Don't write anything. What's the statement that I have given? Therefore, the amount of heat energy needed for 3 kilograms of the object to increase the temperature by 10 degrees Celsius. Isn't it? To increase the temperature by 1 degree Celsius, for 3 kilograms, we want 700 into 3. So what is the next change in number here? Now, the 3 kilograms is there, but temperature is increased by 10. Enough? To increase the temperature by 1 degree Celsius, for 3 kilograms, we need 700 into 3. To increase the temperature by 10 degrees Celsius, we should multiply this number by 10. This should be multiplied by 10. Is it clear, or may I again explain? Would like if I explain it again? Anybody in the class? Okay, see, try to understand the flow here. Let me explain again. Try to understand the flow. If the mass is 1 kilogram, if you want to increase the temperature by 1 degree Celsius, you just want 700 joules. If the mass is 3 kilogram, if you want to increase the temperature by 1 degree Celsius, that is 700 into 3. Clear? Now the mass is 3 kilograms, but you want to increase the temperature by 10 degrees Celsius. 700 into 3 into 10. Okay or not? That's the process. So if the heat, I want to put one more equation. I want to put one more equation and write the numbers like 3 into 700 into 10. 3 into 700 into 10. Okay? Please write this statement, this equation also. Put the mark and write the numbers into this order. Right. So if the heat energy needed for this process, if the heat energy needed for this process is Q, then Q is given by the product 3 into 700, 3 into 700 into 10. Write this equation, draw box around it. What is 3? 3 is the mass. 3 is the mass. What is 700? Specific heat capacity. Specific heat capacity. What is 10 here? Change in the temperature. The change in the temperature. Listen here, sometimes you may have heard this equation. Heard means your O-level science teacher directly give this equation, you put numerical values and you do the calculation. That is listening, hearing, or you heard it. Learning means you should know how to prove the equation. You must have the ability to understand each and every step of this system. The proof. You should know how to prove the equation. You must be able to explain all the steps nicely in simple words. Then only you know it. Otherwise, it's something that you have learned. So that is not the way of learning science. Science means you must be able to explain it. You must be able to prove it. So we have successfully proved even our fourth equation. Second example, example number 2, under specific heat capacity. Please write the specific heat capacity. The specific heat capacity of a certain plastic. The specific heat capacity of a certain plastic is 300 joules per kilogram per Kelvin. Whether it is per Kelvin or per Celsius, no problem. The specific heat capacity of a certain plastic is 300 joules per kilogram per Kelvin. Full stop. It is needed to increase. It is needed to increase the temperature of. It is needed to increase the temperature of 4 kilogram of that plastic. It is needed to increase the temperature of 4 kilogram of that plastic from 30 degrees Celsius to 36 degrees Celsius. It is needed to increase the temperature of 4 kilogram of that plastic from 30 degrees Celsius to 36 degrees Celsius. How much heat energy is needed for that process? How much heat energy is needed for that process? So here, don't do anything, don't write anything, just listen to me. There is 4 kilogram of plastic which is at 30 degrees Celsius temperature. There is some plastic. So we provide heat energy. We provide few joules of heat. Then the temperature of this 4 kilogram of plastic increases up to 36 degrees Celsius. Clear? Starting temperature 30, ending temperature 36. So therefore, what is the increase in temperature? Come on, don't write. What is the increase in temperature? Increase from 30 to 36. Yeah, increase in temperature is 36 minus 6 degree Celsius. So this is the solid plastic given in this equation. Draw this figure. Draw the figure and mark the given data. We want to increase the temperature of 4 kilogram of plastic by
63 Celsius. That's what we have asked. So here we are going to write some statements and obtain the final answer. Right, below the figure, please write the first statement. Below the figure, please write the first statement. The specific heat capacity. The specific heat capacity of plastic. The specific heat capacity of plastic is 300 joules per kilogram per Kelvin. The specific heat capacity of plastic equals 300 joules per kilogram per Kelvin. What does it mean? What's the meaning of this statement? The specific heat capacity of plastic. What does it mean here? The meaning of this is, right? Look at board. Therefore, the amount of heat energy, needed to increase the temperature of 1 kilogram of the plastic by 1 degree Celsius or 1 Kelvin is 300 joules. Look at board, please don't write anything. Listen to me carefully. What's the meaning of this sentence here? The specific heat capacity of plastic 300 joules per kilogram per Kelvin or per Celsius, no problem. The meaning of this black color statement is the amount of heat energy needed to increase the temperature, right, of 1 kilogram of the plastic by 1 degree Celsius is 300 joules. Correct? Write those statements here. Write those statements. Right. Then the next statement, don't write the syllable, look at what, please don't write anything. So the next statement is, therefore the amount of heat energy, therefore the amount of heat energy needed, please don't write anything, just look at what, therefore the amount of heat energy needed to increase the temperature, of 1 kilogram, temperature of 1 kilogram of the plastic, 1 kilogram of the plastic by not 1 degree Celsius but by 60 degrees Celsius. Therefore, the amount of heat energy needed to increase the temperature of 1 kilogram of the plastic by 60 degrees Celsius. Look at board and answer my question. To increase the temperature by 1 degree Celsius, it wants 300 joules. To increase the temperature by 1 degree Celsius, it needs 300 joules. Therefore, to increase the temperature by 6 degrees Celsius, how much heat energy is needed? To increase the temperature by 1 degree Celsius, 300 joules needed. To increase the temperature by 60 degrees Celsius, it wants 300 into 6. Am I right? Write the statements, write them all. Write them all. So what is the next statement? I think you have understood the concept here. So look at board. Look at board. Final statement. Listen to me carefully. Do not write anything because I'll definitely give you more than enough time for it. The next statement is, I'm writing this similar statement. Look at it. Therefore, don't write, listen to me. Therefore, the amount of heat energy needed, the amount of the heat energy needed, the amount of heat energy needed to increase the temperature of, to increase the temperature, of, here I have written 1 kilogram. Here I have written 1 kilogram, but the question is given as 4 kilograms of the plastic. So I will write that the temperature of 4 kilograms of the plastic Here I have written by 6 degrees Celsius. I will not change it. By 6 degrees Celsius. Don't write anything. Listen to me. Try to understand the concept. To increase the temperature of 1 kilogram by 1 degree Celsius, we want 300 joules. To increase the temperature of 1 kilogram by 6 degrees Celsius, for 1 degree you want 300. For 6 degrees you want 300 into 6. 300 into 6 is needed for 1 kilogram. Therefore, 4 kilograms you want 300 into 6 should be multiplied by 4. For 1 kilogram, we want 300 into 6 joules of heat. Therefore, for 4 kilograms, we want 300 into 6 into 4 joules of heat. Let me write these numbers in this order. 4 into 3 into 6. No difference. Eh? Whatever the order of the numbers, as they are multiplication, you get the same. This is the final statement. Write them all, read them all again, check whether you can understand everything. Right? Read all the statements, check whether you can understand them. Very, very important. Look at board here. So, the amount of heat energy needed to increase the temperature of 4 kilogram by 6 degrees Celsius is given by the equation 4 into 300 into 6 multiplied. So, if the heat energy needed for this process is Q, Q is given by the product 4 into 300 into 6. Let's write this equation. Draw a box around it. 4 is the mass of the substance. Mass. 300 is the specific heat capacity. Specific heat capacity. 6 joule is the change in temperature. Maybe it is, maybe it is. The change in temperature. This is the order. Mass into specific heat capacity into change in temperature. Now let's try for the third example. Example number 3. Is right. The specific heat capacity of a certain substance. The specific heat capacity of a certain substance is, look at board. The specific heat capacity of a certain substance is, look at board, C joules per kilogram per kelvin. You can go that right. C joules per kilogram per kelvin. I'm giving an example, so you like statements, right? Specific heat capacity of a certain substance is C joules per kilogram per kelvin. Full stop. It is needed to increase the temperature of. It is needed to increase the temperature of simple m kilogram of that substance, simple m kilogram of that substance by theta degree Celsius. It is needed to increase the temperature of simple m kilogram of that substance by theta degree Celsius. Full stop. Obtain an expression for the amount of heat energy needed for that process. Obtain an expression for the amount of heat energy needed for that process. Write these statements as in the previous example. Write all the statements as we have written in the second example and try to obtain an equation like this. Right here. Do it yourself. The first statement should be the specific heat capacity of plastic. The specific heat capacity of plastic is C, unit joules per kilogram per kilo. The meaning of this sentence, can be explained by this statement. The amount of heat energy needed to increase the temperature of 1 kilogram of the substance. They have said substance mean maybe water, maybe glass, maybe plastic, maybe water. As those things are substance. Therefore, the amount of heat energy needed to increase the temperature of 1 kilogram of the substance by 1 degree Celsius is C joules. So that is the mean. These two are equal. The amount of heat energy needed to increase the temperature of 1 kilogram of the substance by 1 degree Celsius is C joules. Enough? Therefore, the amount of heat energy needed to increase the temperature of 1 kilogram of plastic should be the substance, right? Therefore, the amount of heat energy needed to increase the temperature of 1 kilogram of the substance by 10 degrees Celsius. To increase the temperature by 1 degree Celsius, C joules of energy is needed. Therefore, to increase the temperature by theta degrees Celsius is the heat energy needed is C into theta joules. We have written that statement also correctly. The three statements correctly. Again, we got the three statements correctly. So this is the heat energy needed for 1 kilogram, right? Then how much heat energy is needed for simple m kilogram, right? By 6 degrees Celsius. Therefore, the amount of heat energy needed to increase the temperature of m kilogram of the substance, by 10 degrees Celsius. How do we find it? To increase the temperature by 1 kilogram, you want CD. Therefore, to increase the temperature by m kilogram, you need C theta should be multiplied by m. Normally, we write the equation in this format: m into C into d. Who has written this statement also correctly? Finally, the amount of heat energy needed for this process is given by the product m into C into d. What's the equation there? Final equation is U equals m into C. Which write this equation, row books around it. That's it. So this is the fourth equation that we wanted to prove. We have it. Now we have obtained all the four required equations. Now I would like to write the four equations as a summary. Got it here? I have obtained all the four equations. Now I'm going to write all the four equations together as a summary. After that, I'm going to use the four equations to solve some problems. Look at board table. Look at board. Summary. The first equation that I have obtained is the, don't write, heat capacity equation. What is the heat capacity equation here? Q equals S theta. What is S? In heat capacity of an object. Do you remember this equation? What is the second equation that I have obtained? Q equals simple ML. Somebody please write what the L is. Write the equation and find what the L is. Name it. Start writing the summary. Start. The term simple L is known as specific latent heat of fusion of a solid. It is known as specific latent heat. Specific latent heat of fusion of a solid. Fusion of a solid. What does it mean here? It is the amount of heat energy needed to convert 1 kilogram of solid completely into its liquid at its melting point. What is L here? It is the amount of heat energy needed for 1 kilogram of a solid to convert completely into its liquid at its melting point. If L is the heat energy needed for 1 kilogram, ML is the heat energy needed for n kilograms. Correct? Then what is the third equation? Third equation, U equals capital NPL. Somebody please tell me what the capital L is. Huh? What is capital L? Same name. What? Specific and latent heat. Specific latent heat of vaporization. Vaporization of a liquid. What is capital L here? Specific latent heat of vaporization of a liquid. Okay, write the three equations. Right. Today we have put the fourth equation also. So altogether how many equations? 4 equations. The fifth equation next week. The fourth and the last equation is this. U equals MC. I have named all the parts, so I can simply erase. Then I have completed the sum. U equals MC data is the fourth equation. M is mass, C is specific heat capacity, theta is the change in temperature. This is the summary. Okay, dear? Right, now let's try some examples. Yeah. Example number 1. Example number 1. The heat capacity of a certain solid cylinder, the heat capacity of a certain solid cylinder, the heat capacity of a certain solid cylinder is 400 joules per degree Celsius. The heat capacity of a certain solid cylinder is 400 joules per degree Celsius. Full stop. How much heat energy is needed? How much heat energy is needed to increase its temperature? How much heat energy is needed to increase its temperature from 30 degrees Celsius to 36 degrees Celsius? How much heat energy is needed for it to increase the temperature from 30 degrees Celsius to 36 degrees Celsius? Look at what here. There is a certain cylinder. What is the heat capacity? 400. What is the mass of the cylinder? Nothing. Mass of the cylinder is nothing. So we provide some heat energy. Then the temperature of the cylinder should be increased from 30 degrees Celsius to 36 degrees Celsius. Draw this figure here. Initial temperature 30, final temperature 36. In an increase in temperature, what is the increase in temperature? Therefore, the increase in temperature, that is 6 degrees Celsius. Go to the So you can use this equation directly. S equals, so Q equals ST. Now you can directly use that equation to find the heat energy needed for this process. Right? You can directly use that equation to find the heat energy needed for this process. What's the equation? Q equals ST. S is the amount of heat energy. S is the amount of heat energy needed to increase the temperature by 1 degree Celsius. So if S is the heat energy needed to increase the temperature by 1, heat energy needed to increase by 3 degrees Celsius is ST. Right? So to increase the temperature by 1 degree Celsius, it wants 200 joules. To increase the temperature by 6 degrees Celsius, you just multiply by 6. 6 times 4 is 24 doubles to 2200 joules of energy is needed for this process. Simple, right? Example number 2. Who wants more time to write these things here? Anybody wants any more time to write the things on board? No. It's right. The specific heat capacity of water. The specific heat capacity of water is the specific heat capacity of water is, you can put 4200 joules per kilogram per Kelvin. The specific heat capacity of water is 4200 joules per kilogram per Kelvin. Stop. How much heat energy is needed? How much heat energy is needed? How much heat energy is needed for 200 grams of water? How much heat energy is needed for 200 grams of water to increase the temperature from 30 degrees Celsius to 40 degrees Celsius? How much heat energy is needed for 200 grams of water? Come on. To increase the temperature from 30 degrees Celsius to 40 degrees Celsius. Right, look at board. Look at board. There is 200 grams of water. We provide heat energy. Then the temperature should be increased from of these 200 grams of water from 30 degrees Celsius to 40 degrees Celsius. So this figure is this figure. Initial temperature 30 degrees Celsius, final temperature 40 degrees Celsius. Then what should be the increase in temperature? If the initial temperature is 30, if the final temperature is 40, the increase in temperature is 10 to 40 degrees Celsius. Draw the figure. Right here, the mass is given. Mass is given. Therefore, you can directly use this equation U equals mc. Right? The amount of heat energy needed for this process can be found by the equation U equals mc. But there's a small problem. Look at what here. Mass is given as 200 grams. Mass must be kept in kilogram. How do we convert grams into kilogram? Divide by 1000. Specific heat capacity of water is 4200. The change in temperature is 10. Can you do the rest and find the heat energy needed for this process? So we can cancel out the 3 zeros easily. See this? 1, 2, 3, 1, 2, 3. Like that, you can cancel out the zeros. So what are the remaining numbers? 200 into 42. 200 into 42. So now very simple. 2 times 2, 4. 2 times 4, 8. And the double zero. 8,400 joules. What is the answer? Example number 3. The heat capacity of a certain metal cylinder. Next example. The heat capacity of a certain metal cylinder is 400 joules per degree Celsius. The heat capacity of a certain metal cylinder is 400 joules per degree Celsius. Full stop. Some water kept in a plastic vessel. Some water is kept in a plastic vessel. The mass of water is 200 grams and the mass of water is 200 grams and the temperature of water is 30 degrees Celsius. The mass of water is 200 grams and the temperature of water is 30 degrees Celsius. We'll stop. The uniform metal cylinder is heated up to 70 degrees Celsius. The uniform metal cylinder is heated up to 70 degrees Celsius and it is placed in the water in the plastic cup. It is placed in water in the plastic cup. It is placed in water in the plastic cup. Okay, dear? Assume that no heat energy is absorbed by the cup. Assume that no heat energy is absorbed by the plastic cup. Right? First stop. If no heat energy is lost to the surroundings, if no heat energy is lost to the surroundings, what should be the final temperature achieved by the water and the metal cylinder? What should be the final temperature achieved by the water and the metal cylinder? What should be the final temperature achieved by water and the metal cylinder? Right. Read the question for yourself here. Do not answer, read. Please tell me whether the mass of the cylinder is given or not. Have they given us the mass of the cylinder? No. So it means we should use the equation without the term M for the cylinder. Am I right? Mass of the cylinder is not given. So we should use the equation without the term symbol M. So what is the equation without the term symbol M here? ST. Look at what? Initial temperature of the cylinder 70 degrees Celsius. When the cylinder placed in water, what will happen? Its heat energy is given to water. Therefore, the temperature of the metal cylinder reduced. Am I right? So temperature of the metal cylinder reduced. And let's say final temperature of water and the metal cylinder, final temperature of everything, then we take it as theta degrees Celsius. What is the final temperature of everything here? Theta. Or I can say theta F degrees Celsius. F4 final. So what is the final temperature of everything? Theta F degrees Celsius. For example, theta F may be 40. Theta F may be 40. So what is the what's the change in temperature here? Starting temperature 70, ending temperature 40. Okay? If the decrease in temperature is 70 minus 40, right? Something like that. Wait. What will happen to water? There is some water. What is the mass of this water here? Mass of the water 200 grams. Temperature of water 30 degrees Celsius. So this heat energy given out by the cylinder is absorbed by water. So what will happen to the temperature of water? Temperature of water should be increased. Finally, the temperature of water. Finally, the temperature of water and the metal cylinder and everything is theta F degrees Celsius. Got it? So this is the story saying by the question. Please write the description. When the metal cylinder is immersed in water. When the metal cylinder is immersed in water. When the metal cylinder is immersed in water, it gives heat energy out. It gives heat energy out. When the metal cylinder is immersed in water, it gives heat energy out. Full stop. Therefore, its temperature is reduced. Therefore, its temperature is reduced. Full stop. Next line, next point. The heat energy given out by the metal cylinder. Next line, next point. The heat energy given out by the metal cylinder is absorbed by the heat energy given out by the metal cylinder is absorbed by water. Therefore, the temperature of water is increased. Therefore, the temperature of water is increased. Clear? Start going that right. Let us take the final temperature of everything. Let us take the final temperature of everything as theta F degree Celsius. Look at what I write. Let us take the final temperature of everything as theta F degree Celsius. Clear? Now draw both figures. Draw both figures. Here temperature reduced. Therefore, the increase in temperature. You have to find this. Draw these figures and complete these statements. Here temperature increase. Therefore, the increase in the temperature. Increase in temperature. Draw the two figures and fill these statements: the decrease in temperature and the increase in temperature. Exam එකේ මේ වගේ ප්‍රශ්නද? ඔව්. මේවා තමයි ඒක නෙවෙයි. මේක නැතුව ET ගැටුවට පස්සේ සුභාෂිතේ ප්‍රශ්නේ නෑ නේද? නැත්නම් දුක්ඛිත කවුරුගේ ප්‍රශ්නේ නෑ ET ගැටුවට පස්සේ. දැන් ET වල විභාග දෙක එකක් තමයි මේක වෙන්නේ. සමහර ළමයි අහනවා මේ වගේ උත්තර දෙනවා. මොකද නැත්නම් පාස් කරලා බලන්න. Draw the two figures and write them. The increase in temperature and decrease in temperature. Therefore, the increase in temperature means final temperature minus initial temperature. Temperature increases from 30 to theta. Stop everything, look at board here. Temperature increases from 30 to theta F. And an increase in temperature means bigger temperature minus initial temperature. Theta F minus 30. Theta F minus 30. This is the increase in temperature. Yeah. So what about the decrease in temperature? Increase means final temperature is smaller than the initial temperature. Initial temperature is bigger. It is reduced. Initial temperature is large. 70 is large. Heat is given out and temperature decreases. And decrease in temperature is initial temperature, bigger temperature minus final temperature, smaller temperature. So that is 70 minus theta F degree Celsius. Is it clear? Any doubt? Anybody has a doubt about this increase in temperature and decrease in temperature? All right. So then, look at board. Then, let's try two equations. First equation. The amount of heat energy given out by the solid cylinder. The amount of heat energy given out by the solid cylinder. The amount of heat energy given out by the solid cylinder equals line. Mass is not given. So what is the equation that should be used here? The amount of heat energy given out by solid cylinder is ST. So ST is given as 200. The change in temperature is given as 70 minus theta F. Mark this as the first equation. We just want to find what the theta F is. This is the amount of heat energy given out by the metal solid cylinder. We don't know. We cannot be simplified. It's better to make like this. Next equation. The amount of heat energy absorbed by water. The amount of heat energy absorbed by water. The amount of heat energy absorbed by water. Mass of water given. What is the equation that we should use here? MC. The amount of heat energy absorbed by water equals MC theta. MC. The amount of heat energy absorbed by water equals MC theta. M is mass of water, 200 grams. So it should be divided by 1000 to convert grams into kilograms. C is a well-known value. Specific heat capacity of water is 4200. The temperature difference. What's the temperature difference? Theta minus 30. Change in temperature is theta F minus 30. We can write one more step. We can cancel out series. We can cancel out series like 1, 2, 3, 1, 2, 3. So what are the remaining numbers here? The remaining numbers 20 into 42 into theta F minus 13. Mark this as the second equation. Right. First equation gives the amount of heat energy given out by the metal cylinder. Second equation gives the amount of heat energy absorbed by water. No heat lost to the surroundings. No heat is absorbed by the plastic cup. So what is your decision? No heat went to the surroundings. No heat absorbed by the plastic cup. Heat energy given out by the solid cylinder must be equal to the heat energy absorbed by water. That is nobody to take heat. That is nobody to get heat instead of cylinder and water. Got it here? Right? Star point and right. As there is no heat lost to the surroundings. As there is no heat lost to the surroundings. As there is no heat lost to the surroundings. As there is no heat lost to the surroundings. The amount, write the description. As there is no heat lost to the surroundings, the amount of heat energy given out by the cylinder. As there is no heat lost to the surroundings, the amount of heat energy given out by the cylinder is equal is equal to the amount of heat energy absorbed by water as there is no heat lost to the surroundings, comma, the amount of heat energy given out by the cylinder is equal to the amount of heat energy absorbed by water. So it means the amount of heat energy given out by the cylinder, given by equation number 1. The amount of heat energy absorbed by water, given by equation 2. 1 equals to. First equation is 400 into 70 minus theta F. Second equation 20 into 42 into theta F minus 3. Can you do the rest of the simplifications and find what the theta F is? Right? We can cancel out this 20 and zeros. Right? 20 divided by 20 is 1, 400 divided by 20 is 20. That's much easier. Did you see it? 420 can be cancelled out. 20 divided by 20 is 20. 400 divided by 20 is 20. And again, so this is 20 into 70 minus theta F equals 42 into theta F minus 30. Can we divide this 20 and 42? Can we? 20 and 42 can be divided by 40. Right? This 20 and 42 can be divided by 4. Uh, 20 divided by 4 is 5. 70 minus theta. 42 divided by 4 is 7. 6. 9. Yes. 8. 20 divided by 2 is 10. 42 divided by 2 is 21. That is possible. Let's remove the brackets. 10 times 7 is 700. 10 times theta F, 10 theta F. 21 into theta F, 21 theta F. So simple. I'm so happy. 21 into 30. Yes. Just write the 0, multiply by 3. Theta x 1 is 3, theta x 2 is 6. Subtracted. Now, 700 minus 600 that come to this side as positive 630. 21 theta F. 10 theta F comes to this side as minus 10 comes to this side as positive 10 theta F. Let's add 700 plus 630 is 1300 equals 31 theta F. Take 31 this side. 1330 divided by 31 equals theta F.